All right, shall we talk maps? I've got the PowerPoint version, or I've got the super dangerous demo version. It doesn't seem like the night to do the super dangerous demo version, but shall we do it anyway?
Yeah.
What could go wrong? So let's just give up on PowerPoint completely. I'm gonna leave that entirely. And look, I haven't even got Power BI open. Let's open Power BI desktop and I'll talk for a moment while that starts up. So I'm going to talk maps in Power BI. I've been working with Power BI since before it was born, and I've been working on maps pretty much since then as well in Power BI. That is, I'm not a map specialist. I'm not a GIS person at all. I've fallen into this entirely by accident. I blame Microsoft. He's pretending not to hear. So in Power BI, we've got 5 map visuals available to us now in the product. We've got the imaginatively named map visual. We've got shape map. We've got field map. And we've got the ArcGIS map. And then we've got the new kid on the block. We've got Azure Maps for Power BI. Now, I'm going to talk as we go through a little bit of the pros and cons of each of those, mainly the cons. So my first demo, what I want to show is how to put an image on a map or an icon. And unfortunately, we can't use any of those 5 visuals that come with Power BI to do that. But this was one of my first mapping requirements in Power BI. And it's actually a requirement from just over 6 years ago, back in the beginning of 2016. And it was actually the first custom visual that I ever created in Power BI was to get around this requirement of needing to put pictures on the map. So I'm going to give you a bit of a demo of that very first requirement from back in 2016 on how we can do that now in Power BI. So as I mentioned, to do that, we can't use the out-of-the-box visuals. So I don't like having to revert to custom visuals, but for maps, there's not really much of a choice. So I created a map visual called Icon Map. The most recent version of that was released to App Source back in January this year. Since then, it's had over 100,000 downloads. Just hit the 100,000 mark a couple of weeks ago. But this is actually the 3rd incarnation of Icon Map. So I don't know how many downloads it's had altogether, but it's used in an awful lot of places. So to get Icon Map, it's as easy as clicking Get More Visuals. And then there's actually a category in here for maps. And you'll see we've got loads of choices, though, for different types of map. But I'm going to choose mine, primarily because I know it best. But I think it's still probably the best option when it comes to all of the different types of things that you want to do in maps. So I've added the visual, but we haven't got any data yet. So what we're going to put on our map? Well, my very first original use case was the ability to map every single plane in the sky, with a certain manufacturer's engine on board, in near real time. Now, I'm going to do something slightly different today. I was lucky enough last week to present in Denmark in Legoland, which was one of my childhood ambitions. It's a shame it took over 40 years to get there. But when I knew I was going over to Denmark, I wrote a little .NET program to grab every single plane in the sky from the FlightAware API. But I didn't just do it once, because we can do that easily enough in Power BI through Power Query. I did it every 2 minutes for 24 hours. So I've got the location of every plane flying into the airport just outside Denmark every 2 minutes. So let's use that as our data source. And I'm going to take you through the process of loading it in from scratch. So I'm starting from a blank canvas. Told you it could go wrong. So let's head into Power Query. So my little program creates a CSV file for each of those 2-minute slots. So let's go and find that. Right, where are we? We are in Manchester flight data. So I've got a folder containing all of these CSV files. So let's have a little look what they look like in Power Query. We shouldn't need to do too much transformation. So I use the merge binaries little button here in the corner to combine all of these files. So it's just one long table of flights. I'll talk you through the data quickly. Can you read that okay, if I talk through it? Losing my voice already. This doesn't bode well. Don't suppose any chance a glass of water is there? Sorry, Ben. Otherwise, I'm going to lose my voice quite quick. So let's do some cleanup. So we don't need the file name. The first column is time bracket. So this is the time that I captured where those flights were. So we've got 12th of September 2022 at 2 minutes past 5. So that's when I kicked it off. Next column is the flight number of the plane. We've got timestamp. We don't need that. So origin, that's where the plane was flying from. And then on some of those flights, we've got the destination where it was flying to. We've got departure time. We don't need that. We don't have arrival time anyway. We've got the altitude, so how high the plane was. We've got the speed it was flying. We've got the latitude and longitude. And then finally, we've got the heading, so the compass bearing, which direction the plane was pointing. And I think that's probably all we need to do. I'm going to grab one more file though. I've also got a CSV file in here. He says, hopefully, that contains the location of thanks, Ben. No worries. Of every single airport in the world. So I'm just going to load that straight in as well. Airports and flights data, that'll do. It'll take a moment to load, but it's not that much data, so it shouldn't take too long. It will follow the rule though. The more people watching you, the longer things take. And I'm just going to create a relationship between those two. So in my flight data, I've got the destination here, and in the airports table, ident is the 4-letter code of the destination airport. So create a quick relationship between the two. Change the cross filter direction because I'm going to pull some stuff out of the air, some numeric data out of the airport data and relate it to our flights. Right, so we're ready to build our report. Now, as I mentioned, I captured data every 2 minutes. So while we're building things to start off with, I'm just going to add on a quick slicer and limit it so we're only looking at one set of data at a time, just while we're building the report. Just pick one, and then I'm ready to add my map on. So we'll pull on icon map. And I need to configure it. So in the category field, so there's 2 mandatory fields in icon map. There's category and size. So I'm going to pull on the ident, that's the flight number, into the category field. And I'm going to pull in, let's use altitude for a change in the size field. So we've told the map how big we want to put stuff in the size field. We've told it what it's all about, the ident field, but we haven't told it where these planes are. So let's drag in latitude and longitude. And now we get a map with circles representing where those planes were at 2 minutes past 5 on the 12th of September. But we've got circles. I could have done that in Map Visual or Azure Maps. We don't want circles. We want a picture of a plane. So I'm going to go to the formatting options, and here in Object, actually, let me show you what we've got out here on the web. HTTPS. I've uploaded a picture of a plane. There it is. So you can see here, Zoom in. Let me zoom in. No. Well, anyway, I've got a tiny little plane icon. So I'm going to copy that URL and paste it into this image field here on the map. And you can see our circles straight away get replaced by planes. Let's make those slightly less transparent, so they're a bit bolder. Problem with our planes, though, is they're all flying to the North Pole. Pretty sure that isn't what was happening. Hoping they were flying to Denmark or away from Denmark. But we've got that compass bearing in our data here in the heading. So what I'm going to do, because my planes are all pointing north, that's 0, I rotate them around by the number of degrees of the heading, they should point in the appropriate direction. So you can see here, one of the options is image rotation. And I'm going to use conditional formatting to grab the value in heading. Because there's one row per plane, it shouldn't really matter, but I'll choose average anyway, just for safety. And now our planes are pointing, hopefully, in the direction of travel. It's a little bit hard to see where they were going from or to, though. So next thing I'm going to add onto the map is I'm going to use our longitude and latitude of our destination airports. So let's drag latitude on and longitude on, and it's used count. Let's change those to averages. There we go. Now we have a line pointing to their destination. Let's make that a bit clearer. Should we make it bright red? That. And a bit thicker. Can we see that? Yeah. So we've now got planes pointing in the direction of travel with a line towards their destination. What else can we do to this map? Well, there's a couple of things we can do. One of those is I'm going to change the background. So at the moment we're using OpenStreetMap maps, but I'd like to use some satellite mapping. So I'm going to use Mapbox's satellite maps. So I'm going to paste my Mapbox API key that you can get from mapbox.com and switch to satellite. And now we get our planes overlaid on top of satellite maps. On top of that, though, let's go one stage further, and I'm going to add on the daylight terminator. Now, it's already, well, we can see out the window that it's already dark. Actually, let me just flip back to normal maps for a second so you can see that. If I zoom out, it's a bit funny at this time of year. This looks better in the summer, but this dark area represents a part of the Earth that's currently in darkness. And this is updated in real time. Now, obviously, you can't see it at this scale. If I zoom in all the way over Africa, far enough in, you can actually see the line moving across the map, updated every second. So this is real time. If you've got historic data, then you can actually put in the time and date in the field down there, and the curve will show the appropriate shape and the appropriate location for that date and time. Let's flip back to, what was I doing? Satellite mapping. Here's our planes. Let's add one more bit of real-time data, though. So I've got a subscription to openweathermap.org, which gives me real-time weather mapping. And if you sign up for their API, they give you a URL that you can use in your own applications. So I've copied that. And in the overlays section here, I'm going to turn on a custom overlay and paste in that URL. And now we get real-time cloud cover and precipitation. And let's make that white. Oh, this is an old version of Icon Map. The new version allows you to change the transparency. Okay, so we've now got real-time weather. We've got the plane's location, where they're traveling to, point in the right direction. Let's do one more thing to finish this off. And I'm going to add another custom visual, not one of mine this time. I'm going to go back to App Source and grab the play axis custom visual. Anybody use this? It's one of my favorite visuals for demos. I haven't found a real world use for this yet, but it's good for demos. So let's take off my slicer. Let's add play axis on instead and drag on the time bracket field in here. Don't want a hierarchy. Let's stick to the time. We need to change the visual interactions. So I want to filter my map based on the time here. So just flip that to filter. And then I think the only other thing I want to do is, let's see if we can manage this with Teams running in the background. I'm going to hit play and hopefully, oh no, one more thing. If I hit play now, as the planes start moving around, the map's going to jump all over the place as the planes move around. So I'm going to go into the zoom options on the map and just tell it not to move the map now. So it will stay here with everything on the screen. Zoom in slightly. All right, let's do this. Hit play, and there we are, sped up by a lot. Our 2-minute time slices over 24 hours of every single plane flying into Billund Airport in Denmark, animated in Power BI. No crashes. Now I could sit and watch this for the rest of the evening, but should we try and do something a bit different? All right, I think we're finished with that. Let's close that one down. I'm not going to start the next one completely from scratch, or we'll run out of time. And this one's quite a lot of data, so I'm loading in, what's this, 120 meg Power BI file. What this one's got in it is all of the property sales for the last, I don't know, quite a lot of years for the whole of the UK. And I've linked it up to Ordnance Survey's postcode database. So we've got every single residential property that's been sold in the UK for the last however many years, and its longitude and latitude, which I've found out from its postcode. So we can start to plot things on the map. And no surprise, we're going to use Icon Map to do this. And I'll tell you why we need Icon Map for this one. So what I want to do this time is, instead of putting images on the map, I want to create something called a choropleth map. So choropleth map is, instead of drawing bubbles like we saw before before I put the icon on, like the big map does, instead I want to draw boundaries, so shapes of areas on the map, and then colour them with different levels of intensity based on the average house price in that area. And we're going to start high. I'm going to really do this in Manchester, but my geography of Manchester is not good enough to do that. I'll admit that, despite having lived here for 3 years. I'm going to do London, and then we'll move out to the rest of the UK. Now, if I wanted to do this in the out-of-the-box visuals, I do have some choices. Actually, the Esri map, the Esri map has quite good support for certain boundaries in the UK. It supports local authority areas quite well, and it supports some of the statistical geographies quite well too. But anything custom, you can't do unless you've got an ArcGIS subscription, which costs quite a lot of money. Where's the mute button? Our other choice, though, is, well, should we have a look at what this would look like with a field map? I'm going way off script here. This could go badly wrong. What have we got? In my data, I've got London boroughs. Let's start there. And if I want to map those by the average house price, let's not do that. This should be enough anyway. If I zoom in here, I'll show you what the problem is. If I want to map my local authority areas using the field map that comes with Power BI, this is supposed to be every single London borough. Interestingly, we've got some tiny little ones, and we've got some gaps, and most of London is missing. The problem is, if you're trying to do this with UK geography, we're reliant on Microsoft guessing, to be frank, what type of boundaries we're trying to plot on the map. and Microsoft also keeping them up to date for every single region in the whole world that Power BI supports. It's probably an unreasonable ask of Microsoft. And if we were trying to do this with like custom sales territories or something that's, you know, entirely proprietary to your organization, well, Microsoft aren't going to know these. You've got to provide them yourself, but you can't provide them yourself for a field map. You can't provide them yourself, unfortunately, yet for the Azure map visual either, unless you don't want to interact with it and you just want them in the background behind your bubbles. The only option we have out of the box is to use ShapeMap. The problem with ShapeMap, it's been in preview since 2017, and clearly it's never coming out of preview. So, hence, we're back here with Icon Map. So let's have a look at some different strategies for doing this in Icon Map. So I'm going to configure it the same. I'm going to drag on my London boroughs, and I'm going to drag on average house price. And at the moment, it doesn't know where to draw anything because we haven't given it those custom boundaries yet. Oh, London Borough is like the local authority name. It's like Rochdale or Greater Manchester. That's as good as my local geography gets. And you'll see them hopefully in a moment. So I've gone off to Ordnance Survey website again, one of my favourite places for maps, downloaded the custom shapefile, and I'll show you how to convert them in a moment because things get a little bit tricky when it comes to downloading things in the UK because Ordnance Survey use a different type of projection and a different coordinate system to most of the maps on the internet. I'll show you how to translate it in a sec. But let's see it in action first. So I've downloaded the file, I've converted it, I've uploaded it again onto my web storage. And therefore I now have a URL pointing for that file. So it's a GeoJSON file. And if I go to the Icon Map formatting options, turn GeoJSON on and paste the URL in here, it will load them up and give us our London Borough boundaries. And then all I have to do is go into the formatting options and I can use conditional formatting to base that on the average house price. There we are. Hover over here and we can see that the average price of a house in the City of London is very scary. And we can go one step further. So we can actually do this in the Esri map. It understands the London Borough boundaries fine. But one of the frustrations I have with the Esri map is a lot of the capabilities you get in all the other out-of-the-box visuals, like drill through, drill down, report page tooltips, aren't supported. So if you want to have drill down, you're still reliant on custom visuals. So I've got the next level of geography down. So this is called a lower super output area, which is meaningless to anybody who doesn't work in local government statistics, but it's a breakdown of local authority areas based on population. So the idea is the number of people that live in each of these areas is roughly the same regardless of where it is in the country. So some will be big where hardly any people live. In London they'll be tiny and lots of them because it's densely populated. So let's paste in our URL for our more detailed GeoJSON file. So we're down in here. You see it says number of levels, number 1. I'm going to increase that to 2, and it will give me another box to paste a URL in. Just need to make the map refresh by flipping to another page and back again. And the only other thing I need to do is pull in that field underneath my London boroughs here to create the hierarchy. And then Power BI will give me my drill down icon. I can click on here and zoom into one of these London boroughs. And then we get the more detailed view. And we've got some formatting options in here. I can tell it to get rid of all of the shapes that we're not interested in because we've just drilled down into Westminster. So this works quite well. I'm fairly happy with this. Let me show you how to create these GeoJSON files then. So I rely heavily on a free tool on the web called mapshaper.org. So let me give you a very quick run through on how to convert the files. So I've downloaded the files from Ordnance Survey. It comes in a zip file, so I've just unzipped everything. And these are all of the files that make up all of the local authorities in the UK. Not being a GIS expert, I don't really know what's in all of these. So let's just drag them all into MapShaper. Hit import. And boom, here's all our local authority areas. And I could just export it. I could just export it here in GeoJSON and be ready to go. But the problem with that is, I don't know if you noticed, but we've got 70 odd megs worth of file here. If I export this as GeoJSON, it's going to be even bigger. Nobody wants to be sat waiting for a Power BI report to load 70 megs worth of shapefile every time we open a report or switch to a report page. So we need to make it smaller. This is really easy in MapShaper. There's a simplify button here in the corner. So if I hit that, we get this little slider at the top. And if I zoom in, you'll see as I drag this across, the shapes get really simple. So we start with complicated and drag it across. And you see we're here 18% of the original size, and I can't tell any difference. We can get all the way down, and it's only now when we start hitting like 5% that some of the detail starts going. So you need to find the compromise between detail and file size, something sensible. And then you're ready to export, except not quite. Now, you remember I mentioned in the UK, we have Ordnance Survey. So Ordnance Survey have their own coordinate system that's eastings and northings. They're not longitudes and latitudes. So we need to convert it first. And we can still do that in MapShaper as well. We just use a little reproject command and tell it we want WGS 84. It says, trying to remember the command on the fly. Perhaps it's just proj WGS 84. There we go. It reprojects it, and now I can export it, download it onto my computer, upload it into something like Azure Storage or GitHub, somewhere that's publicly accessible, and then we can use it in IconMap. So it really doesn't take very long once you know how to do it to convert your files. So this works quite well if we're looking at a small area like this, like London. I can get my GeoJSON files small enough that I can cope with London. But if I want to display, especially that lower level, remember our super small shapes here. Imagine how big the file would be if I had the whole of the UK and wanted to put that in a GeoJSON file. It's going to be hundreds and hundreds of meg, if not more. It's not a suitable solution, unfortunately, for doing the whole of the UK at any one time. So we've got two options now that we can do with IconMap to support a different way of displaying shapes than GeoJSON files. One of those is to rely on an external map server, like Esri's ArcGIS, or an open source one, such as GeoServer. Or map subscriptions like Mapbox can do this too. So let's come back out of here, and I'm going to turn off my GeoJSON layer. And instead what I've done is I've taken that super detailed low super output area for the whole of the UK, and I've uploaded it into my open source GeoServer that I have running in the background, which gives me a URL for something called vector tiles. Now, the way map backgrounds work is all of these maps come off a map server, and they're all broken down into little squares. The squares always stay the same size, and when you zoom in, you get more and more detail in each of those squares. Now, vector tiles work exactly the same way. So instead of returning back background maps, I'm going to get those shapes. But the difference with vector tiles is that instead of containing, I mean, these are JPEGs or PNG images that you can't interact with, it just comes back with the actual coordinates of the outlines for just the area shown at the map at any one time, which means you can hold the whole of the UK back on your map server, but it's only ever sending the bit you're interested in at any one time to the map. So, right, let's see if I can do this in the demo. So I'm going to turn my vector tile layer on, paste in my URL, and instantly, let's zoom right out, you'll see we've got these tiny little shapes for the whole of the UK being rendered. The other nice thing is you don't need to worry about, remember that slider where I was trying to make them more or less detailed to make the file size small? Because the map server handles that for us on the fly, it doesn't matter how detailed I get, we don't lose any of that level of detail. That's all handled on the fly as you zoom in and out. The only thing we don't have now is our data aligned to it. So let me switch, instead of looking at London to the whole of the UK, take off London boroughs, and we will get those lower super output areas starting to be shaded. The problem we've got, though, is we're still hitting a Power BI hard limit. Power BI visuals can only display 3,500 rows of data. 30,000 rows of data on any one visual at any one time. And I can't remember how many of these are in the UK, but there's more than 30,000. So we've got gaps on here. So these grey bits are where we've run out of data, and probably here on the map, there it is. We've got the little eye icon, which says that they'll be showing a representative sample because we've got more than 30,000 rows. So I haven't got a workaround for this. The only thing I can suggest is that we only look at a certain amount of data at any one time. So if I pull in district, that should give me a list of all of the councils. And if I pick, right up, my map's gone. Come back, there we go. So if I click,
Greater Manchester.
Yeah, let's do Greater Manchester. Can't see Greater Manchester. I'll tell you what, let's go with the other choice, Rochdale. There we are. Northeast Manchester. If I zoom in here, hopefully. Where is it? Oh, I'm in London. Hang on. So used to scrolling there. Manchester. Come on, map tiles. Where are you? There we are. So there's Rochdale shaded. Now, interestingly, I'm having to navigate around the map to go and find Rochdale. It hasn't automatically zoomed in there. And there's a reason for that. Because unlike the GeoJSON method, where all of the coordinates for the whole of the area you've loaded are known by the map visual at any one time, it knows when you say, I want to see Rochdale, it knows, here's Rochdale, here are all the coordinates for it, let's go and find it. But when you use this tile method, it only knows about what it can see on the screen at any one time. So if I'm down here in London, I ask it to look at Rochdale, well, it doesn't know anything about Rochdale. It doesn't know where those coordinates are. So I've added in a little bit of a cheat here. Because we've got longitudes and latitudes in our data, if I drag these into the longitude and latitude fields, well, the default behavior is it draws circles. But if we're using vector tiles, then I can tell it that if we've given it longitudes and latitudes as well, instead of drawing them as circles, instead use them as the center location of where we're looking. So now if I switch to, let's do Salford, it knows where to go and find polygons that it needs. So we get something pretty close to the original behavior that we had with the shapes. So this gives us an option for mapping quite detailed polygons on much greater areas. I've done the UK, it would happily render the world, or whatever, or go all the way down and look at something really detailed if you wanted to. But it gives you the option for hosting much bigger data sets than you can do in a GeoJSON file. The only downside with both this method and the GeoJSON files is they need to be publicly accessible. Because Power BI is a cloud service, the requests for the maps come from your local machine. So the local machine here in Robert Walters in Manchester needs to be able to access my map server, which means my map server needs to be publicly facing. But what if my data is sensitive? What if these weren't local authority areas? Perhaps they were, sorry? Postcode. Well, not even postcode, something secret. What about oil fields or the location of Nord Stream 1 or something like that? You know, something that you really don't want to be public facing on the internet. So we've got a way of doing that as well. But the only safe way of doing that easily is to actually load those polygons into your Power BI dataset. And then they're contained inside your Power BI data model with all of the security that you get out of the box with Power BI. Now, I'm not going to try and build that on the fly, given the time. Let's have a look at, here's one I made earlier, but I'll show you how it's built. So I'll show you running first, and then I'll show you what the data looks like. So same thing. We've got our local authority areas for London, but this time we've got no external resources at all. These boundaries are contained within my Power BI dataset. And not only do we have the boundaries of our local authorities, I zoom in, we've also got the boundaries of our low super output areas stored in my dataset. But I got one stage further. This is still house price data, by the way. It's the same data set. If I zoom in, I went probably as extreme as I could possibly go. I've got the outline of every single building, tree, street light, everything that made up that OpenStreetMap data set stored as polygons in my data set. So let me flip that round to, instead of it being a heat map, if I color those objects by their type, this is the beauty of having all of your polygons in the data. You can just use conditional formatting to change the colors on the fly. If I zoom in now, you can actually see all of these individual buildings, trees or street lights or parks or schools, whatever it is, are all in my data set, which also means I can link them back to other data in my data set. So if I wanted to know, well, first of all, I've got tooltips, which is rather nice. So I can mouse over a house and see exactly what it is. This one is Dream Community Charity Shop. But the other thing I can do is I can use the lasso tool and draw around a bunch of houses. And then I can link that back to my house property data, and it will tell me the price for those actual individual houses that I've highlighted over time. So do you want to have a look what that looks like in the data set? Let's hit edit and go on mouse. Switch to a table. Let's do local authorities because that's probably easier. There we go. So local authority name, and this data is stored in a format called well-known text, abbreviated to WKT. And so for each local authority, I've got a polygon here. You see it says polygon, and then in brackets, all of the different longitudes and latitudes that makes up each of the points to make up that boundary. And one of those for each of the local authorities. Or I've got the same thing for that lower super output area, that level down. And somewhere in here, I can't remember where I built it now, but I've got exactly the same as well for all of the building outlines, all the streets and the rivers and the train lines and everything. Now, obviously, that's quite a lot of data. And I did it for all of London, but I still managed to get it in the Power BI Pro dataset. So it's less than a gigabyte compressed for the whole of London. But if you want to do more than that, and it was 999 meg or something like that, it's close. If you want to do more, well, I'm loading this out of a SQL Server database. This well-known text format is actually a native SQL Server type. if you set a column in SQL Server as geography or geometry, connect Power Query to it, it comes out looking like this. So this is native to SQL Server. You can load in as much data as you want into your SQL Server, add something called a spatial index on it, so it finds it quickly. And then if you create a composite model in Power BI, so all the rest of your data is in memory, but then if you're trying to find all your millions or billions of polygons that you want to have a look at on the map, then you can use a direct query connection for just that table. So you're not limited by the size of a Power BI data set to go and get it. Right, got a few more minutes left. There's a couple more things I want to show. So I've mentioned Ordnance Survey a few times. We're really lucky in the UK that Ordnance Survey release an absolute ton of data. But as I've said, Ordnance Survey use their own coordinate system, which means you've got to convert everything to be able to display it in Power BI. Unless you can tell your map visual that you want to use Ordnance Survey's coordinate system, and then you're fine. Let's go back to our house price data. Let's go back and limit it to London to make life easier for ourselves. So, oops, everything that has a London borough. Let's make life easier for me and start again from scratch. So what I'm going to do this time is I'm going to plot our houses on the map. Let's zoom in somewhere particular. Let's do Sutton randomly. And instead of plotting a choropleth map, I'm going to plot individual postcode locations. So let's drag on postcode. And we'll stick with average house price. Where's that? Average house price. And well, we've got longitudes and latitudes. Let's start there. And we get a circle for every single postcode in Sutton. Let's make those a little bit smaller. So I'm just changing the minimum and maximum size of those. And let's keep them nice and bright so we can see them. There we go. So this is standard, this is normal, this is what we were doing before. What if I want to use Ordnance Survey maps? So if you work for a local authority organisation or a government organisation in the UK, most of them get free access to Ordnance Survey maps. So I have signed up for don't work for a government organisation, but they do have a developer account that you can do demos and try features for free. So I've got, if you've been in the UK a long time or you've grown up here, you'll remember from school days Explorer maps from doing what do you call it? Yeah, Duke of Edinburgh and expeditions and things like that at school. So let's switch our background map to use a custom Ordnance Survey map. And well, nothing happens. It doesn't work. The reason it doesn't work, look, it's drawing it here in the middle of God knows where. The reason it doesn't work is we're using longitudes and latitudes and we're using Ordnance Survey map backgrounds, but we're trying to use the wrong coordinate system. So I just need to go onto the icon map options here and tell it to use British National Grid. And then everything lines up nicely and it knows to plot our points on top of our Ordnance Survey map. So if I zoom out, look, it does all the kind of maps that we're familiar with different zoom levels. But I'm using longitudes and latitudes. I mentioned that a lot of the coordinates are these eastings and northings. I've got these in my data as well, if you want to see what they look like quickly. So for each postcode, come on, here are my longitudes and latitudes. So I think we all know what they look like. Yeah. But here are the eastings and northings. That's that. There we are. Second to refresh. Like 6-digit integer numbers, they're completely different to the longitudes and latitudes. But I can still use these on my map. I just need to take off the longitude and latitude and instead drag my eastings and northings on. And back here where I'm telling it to use the British National Grid coordinates, I just tell it to reproject the coordinates and it will map those back into the format that it needs to understand to display on here. One last little bit of context there on my house price data. One feature I thought it was worth showing is if you've got an external server, now lots of government departments also provide their open data from a map server. But this one's one of mine. I downloaded, I can't remember which department it was. I think it was the Environment Agency. All of the flood data for the UK. So if you now's not the time probably to be buying a house with what's going on in the economy and mortgages, but when you buy a house, one of the things that you pay for is a survey to tell you whether your new potential house is in a floodplain. And all they do is they do exactly this. They find out where your house is and overlay it on top of the floodplain data from the Environment Agency. And you can see whether the house price has any impact on floodplains, which here in Sutton, it doesn't appear to have any correlation, but you get the idea. So we can overlay additional types of information from open sources on top of our map. Right, 2 minutes to go. Let's look at one last thing. So this is my my favorite feature when we start looking at coordinate systems. So we looked at the default one, which is longitudes and latitudes that we're used to using, switched to British National Grid, but there's one other one that I use a lot in Icon Map, and this one here called Simple. And what Simple lets us do is just use X and Y coordinates from the bottom left-hand corner of the map up to the top right, starting at 0, 0 in the bottom left-hand corner. And if we're doing that, well then, we don't really need to use a real map, do we? We do. Let's look at this one. So here we are back in Icon Map, but instead of a map, we've got Legoland Windsor. Just show you the config quickly. So we're still here, Icon Map, and I've chosen Simple. My bottom left-hand corner is 0, 0, which is here. My top right up here is however many pixels wide my background picture is, and however many pixels high it is. So I just put those here on the X and Y extent section, and I've just grabbing the map background as just a flat image that I'm posting up on the internet. Go back to read mode, and we can use all of the features of the map. So for example, here I've got a little lost child, Tom Jones. So I've got my image on there with a label. We can see whether there's any staff members nearby. So here I've got a couple of entertainers that might be able to go and help him. So I can use my lasso tool to highlight those and use my Power Automate button to send them a notification to go and rescue him. I've also got an alert going on here on this ride up here, which turns out to be Hydra's Challenge. Zoom in here. This is a bit of a problem. So Hydra's Challenge is currently closed, but there's 400 people in the queue with a queue time of 50 minutes. So we need to get an engineer to go and fix that ride quickly. So let's have a look where our maintenance engineers are. We've got one here and one down here. So let's add on their maintenance routines to see where they're going to go next. So in the same way as we drew polygons with well-known text, we've also got line strings, well-known text, that allow us to draw lines on the map. So all of the normal functionality of Icon Map, but displayed on a completely fictional pretend map. and it doesn't even have to be a map. I know there's a pharmaceutical company using this, for example, to display microscope slide samples and highlight suspect cancerous cells using the lasso tool, for example. So, you know, it goes well beyond maps. There's all sorts of different use cases for using this. And I started with animating planes. I haven't got any cars, but we could do we could certainly do trains. So come on, I'll finish off exactly the same thing, but with play axis involved. And here's the East Coast Main Line and the location of the trains with a little bit of additional information using icon box label feature. So yeah, lots of opportunity on there. Hopefully I've given you some ideas of how you can make better maps in Power BI, or not even maps. Thanks very much. Any questions? Well, we got pizzas first, I think. How does it work?
Questions first. Quick question, but then questions.
Any questions?
I'm speechless.
Can you use different pictures?
Sorry?
So when you were using before the planes,
Yeah.
could you use different pictures?
Yeah, absolutely. I meant to mention that. So yeah, all my planes were exactly the same, but they don't have to be. I think I've got an example. So if you use conditional formatting to have a different image on every single row of data, you could have a different picture for each and every one if you wanted to. I haven't loaded this since March, but hopefully it will give you there you go. Starbucks or Costa Coffees, for example. I think there might be some Cafe Neros in there too, but you get the idea. And that's just different URL form for each of those locations. Sorry, was another question at the back?
Using every map.
Yeah.
Can we use your
Icon map, yeah.
Is it free or?
It's completely free, yeah. So it's a project released to the community. There's no charge for using it. So yeah, it's available for everybody to use. Oh, you can use it using Esri data on there as well. Yeah, so you can surface. Yeah, you can. Yeah, use. So I showed all my like vector tiles and polygons coming from GeoServer, but I know lots of people using ArcGIS as well to serve all of those up to icon map. So yeah, you get all of the standard Power BI function with icon map, like drill through and report page tooltips and everything else that you might want to use on the map.
Got a roadmap then. What are you going to do next?
Have a break. No, I'm joking. So the next thing coming is a massive performance boost. So I mentioned Power BI visuals are limited to 30,000 rows. However, if you try drawing 30,000 images on the map, it does start to get a bit slow. It'll handle 30,000 circles fine. If you try and draw 30,000 images or 30,000 really complex polygons, then it'll start to slow down. So I've got some code working. It's quite a big change, but I can now render 30,000 images on the map completely instantly. It blows the performance of all the other map visuals out the water. So that's coming next. So yeah, there's animation examples. You might notice I keep the number of things moving at any one time fairly small, but yeah, 30,000 things updating on the screen at any one time is only slowed down by Power BI's ability to get it to the visual. So yeah, it works well.
Is that the visual or the actual laptop? Being a bit naughty there with my question.
No, so
So the Java engine that's rendering that on the front, or is that?
so at the moment it's a combination of everything. So I'm using a open source library called Leaflet to render the maps, and that's the slow bit when it's rendering 30,000 images. I'm still using Leaflet, but I'm using a add-on for it called WebGL add-on, which uses the laptop's graphics hardware to render the images instead on top of the map. And by doing that, you take out all of the latency of JavaScript to be able to do it. But you still got to get the data from the Power BI data set in the service over the internet to your web browser. So you're limited by the underlying speed of a data set, the complexity of your data model and your DAX, and the speed of the internet, and whether you've got Teams running.
How many layers can you use at the same time?
At the same time, you can only, well, it's a slightly complicated answer. So you can have lots of different things displayed on the screen at any one time. Actually, if I've got it open still. So on here, I've got a line, I've got a polygon, I've got a label, I've got a couple of images, and I've got circle. So you can have all of the different objects on there, and you can have that on a map background with one overlay of one protocol, vector tiles as well, and something called a WMS layer, which is how my flood data was rendered. But if you're going to render lots of different types of interactive objects like this, the only constraint is every single object has to have a row of data in the same table. So it's a little bit nasty in that you need to probably restructure your data just for the purposes of showing a map. But the limitation here is how Power BI works, and you can't have multiple independent data sets in one visual. They all have to be linked in some way, which is what the category field does.
So for example, before you put the layer for the flooding, could you use another similar layer to that one at the same time, or you only can have one of each?
So normally one of each, but that particular protocol, if they're all coming from the same server, it allows you to, so the protocol there was WMS, and it actually allows you to request multiple layers at the same time from the map server, and it combines them into a single image. So it's a bit of a cheat. It's one layer, but you can combine multiple on the server side, if that makes sense.
Thank you.
If you've got a use case, though, for more, let me know, because I can always add more functionality in.